Hi students, last class we discussed about current electricity. In that previous class we learned about electric current, isn't it? The symbol of electric current is I. The definition of electric current is the rate of flow of charge within a cross-sectional area. So that is I is equal to dq by dt. Last class we are seeing that one. Then the current unit, the ampere, the unit of current is ampere. That also we saw. Then today we are going to learn about drift velocity. This is also what is the reason of current. The all topics are interlinked. So this is also the same topic, the previous topic, electric current, the reason of electric current, but this is a new physical quantity, that is drift velocity. Okay. Consider a metallic conductor. So this is metal. Metal means conductor. The metal have free electrons, isn't it? The free electrons is randomly moving here and there in that material, because this is not in electric field. If I apply the electric field, means the electrons moving in a particular direction, so it creates some current, isn't it? So this is conductor. These are the free electrons. This is moving here and there. This moving that right side. This is towards left side. So cancel each other. Therefore, net current is zero. Like that, the total amount of current inside the material is zero. Now I am going to apply a battery, that is potential difference. I apply a potential difference V across the material. Now a electric field is created by the potential. That electric field, the direction of electric field is positive to negative. This is positive, so this is negative. Therefore, the electric field direction is like that way. The electron is negative charged particle, so it is moves from negative terminal to positive terminal, isn't it? Now electrons are always moving opposite direction to the electric field. So electric field direction is this. Therefore, all electrons trying to move the opposite direction of electric field. So already it is a random motion. So suddenly it is moving opposite to the electric field. That time it is turned. It is turned that direction. Then this is also that direction, and here. So that times all electrons, free electrons are colliding with each other. The electrons moving or free electrons is released from the atom, means the atom get a positive charge, that is become a ions, positive ions. So the ions also attract the free electrons, and electron also collide each other. So some energy is dissipated inside the material. Okay. So that time all are moving that same direction. That time it is moving some slow, that is slowly it align the particular direction, so it is moving that side. Okay, so electric field is that side. So drifter, that is electrons are drifted towards the positive terminal when applied electric field. We are applying the electric field, that times electrons are drifted. Drifted means that is a pulling force. So electrons are pulling towards the positive terminal. When electric field is applied, that is drift velocity with a particular velocity. Okay, the definition of drift velocity is the average velocity acquired by the electrons inside the conductor when electric field is applied. When we apply electric field, that time only electrons are moving in a particular direction. The total electrons, that is total electrons are moving in same direction. Therefore, the net current will be produced. So that is the reason for electric current. The drift velocity is denoted by Bd. That is velocity. Then drift means d. So the in subscript d. Okay, Bd. Its unit is velocity means meter per second. In our book, the unit is not available, but in 1 mark often ask that meter per second, that unit of drift velocity. Okay. Now this is tau, that is time. The symbol of time is a t, but here tau, that is mean free time. What is called mean free time? The average time between successive collision. Here, when we apply the electric field, that time electrons are trying to moving in a particular direction. That time electrons collide with each other. So the average time between successive collision. Successive collision means that 1 to the near collisions. So that is successive collision, often or consecutive collision, like that we asked. Oh, sorry. Yes. The successive collision means adutha collision. Okay. So average time between successive collision, that is tau. That is known as mean free time. Mean free time is a one topic, that is a physical quantity tau. Its unit is second. Okay. Force in kinematics we learned F is equal to ma. Force is equal to ma. So A is equal to acceleration is equal to F vector by m. Then we know that force, electrostatic force, F is equal to charge into electric field. The charge of electron is minus E, therefore here minus E electric field by mass. Then velocity means acceleration into time. So drift velocity is equal to acceleration of the electrons under time. The time is mean free time is equal to, we substitute that acceleration expression minus E capital E vector by m. Therefore this is acceleration, this is time. So I take out the electric field, because electric field will be a constant one. So I take that electric field outside, therefore E tau by m. This term is considered as mu. Mu is a mobility of electron, because electron only moving, that is mobile charge. The current is due to the mobile charge. So this is mobility. It is a number, the speed of electrons. So mu is equal to E tau by m, that is mobility. The definition of mobility is given by this expression. So mu is equal to modulus of, we take the magnitude only. So modulus of drift velocity by modulus of electric field. So mu is equal to, if the electric field is one unit electric field, that is 1 Newton per coulomb or 1 volt per meter. So both are same. The unit of electric field is Newton per coulomb or volt per meter. So if electric field is unit electric field, means the drift velocity is equal to mobility, isn't it? So mobility is defined as the drift velocity per unit electric field. That is very simple. The unit of electric mobility, the unit of mobility is very important. 1 mark. So velocity unit meter per second. Then electric field unit Newton per coulomb or volt per meter. In our book, volt per meter is used, because here we are going to learn about current, then voltage, like that way. Therefore we use that volt per meter, not Newton per coulomb. So volt per meter, therefore volt per meter. So this is in denominator meter power minus 1. So it becomes meter power 2, then volt per volt power minus 1, then second power minus 1. So the unit of mobility is meter square per volt per second. Okay, well? Yes. Then that is over. But now we are discussing about our real life applications. In reality, our typical velocity of electron, that is typical drift velocity, is 10 to the power of minus 4 meter per second. But when we switch on the bulb or a lamp, that time suddenly the bulb is glow, isn't it? This is the typical velocity. If electrons moving that velocity, means when I on the switch, then the current, the bulb will glow after 1 hour or 2 hours, because the electron moving that very low velocity only. But how the bulb is suddenly is glow, because that is not electrons is moving from one place to another place. The energy is transferred from one place to another place. When I switch on the bulb, the energy of the electric energy suddenly go to the and reach the bulb, so bulb is glow. Okay, so electron is moving with a very small velocity only. The misconception in our life, we use lot of misconception. The sentence is not in clear, and a lot of grammar mistake only we are talking. Our mother tongue also we use the sentence with a grammar mistake also. Okay, like that way. In our real life, we often say that battery is source of electron, because here also I told battery supply the electron, like that way. That is not correct. Battery supply some electrical energy only, not electrons. So battery is not a source of electron, but it is the source of electric energy. It supplies the energy, not electrons. Okay, that is misconception. Then another one. Always we use that word. My mobile is not charged, or charge is down. Now that is charging the battery in my mobile, or mobile is charging. That is your mobile means my mobile is in charging. Like that way. That is not a correct. That means that charging we give some extra, that is electrical energy to the battery, not charge, because without charge means my mobile is don't have charge means it is not provide the, or it is inability to provide the electric voltage. So that is not correct. So then how I say, how will we say that one means my mobile is my mobile battery is low energy, or my mobile battery is gives some energy from the AC source. Like that way we say, but nowadays we use mobile is charging only. That also some mistakes. Okay, or yes, that is my mobile is charging means it implies that the battery is receiving energy from AC source, that is electrical energy from the AC source. That is correct. Okay, so revise that one, very important. 2 mark and 1 marks also in that topic. Okay, drift velocity, then mean free path, then expression, then mobility is very important. 2 mark, then unit is very important. 1 mark. Okay, thank you.